There's so much more to explore, like 97,104.
Okay then, let's explore the number 97,104 because why the heck not?
Step 1. Tens and ones.
For the tens and ones thing, it's just the digits. There's a 9, a 7, a 1, a 0, and a 4. Yep, next step.
Step 2. Rectangles.
Okay, for the rectangles part, we're going to have to factorize this thing. Okay, first of all, 97,104. This is 97,100 plus 4, right? Well, this ends in 2 zeros, so this is a multiple of 100. And 100 is a multiple of 4, so this is a multiple of 4. And of course, 4 is a multiple of 4, so multiple of 4 plus multiple of 4, so a multiple of 4. Which means 97,104 can be divided by 4. So let me just take out my calculator here. It says 97,104 divided by 4 equals 24,276. So it right as 4 times 4 76. But I'm going to write the 4 as 2 squared because that's what you do when you're factorizing. 2, 4, 6. Well, this is still even numbers, which means I can still divide by 2. But also, we can just look at the last 2 digits. It's 76. 76 is 4 times 19. I'm pretty sure you all memorized that while making family. The 76 is. In my box. This is 24,200 plus 76. So this is another multiple of 4 plus multiple of 4, still multiple of 4. This is the divisibility test for 4 actually. Just look at the last 2 digits and you're good. Now we just divide 24,276 by 4 again. We get 6069. So this is 2 squared times 2 times another 2 squared times 6,069. Well, this is an odd number, so you can't divide by 2 anymore. But look, this is a 6, this is another 6, this is 9 and 2. What do these digits have in common? They're all divisible by 3. And if all digits are divisible by 3, this is definitely divisible by 3. Okay, let's merge these two first. This is 2 squared times 2 squared, 2 plus 2 is 4, so 2 to the 4th power times, okay, we can take a 3 out of this, 6069. 6 divided by 3 is 2, 0 divided by 3 is still 0, 2, 9 divided by 3 is 3, 2023. Okay, now what can we factorize anything else out? 2023. Let's see. Obviously, we can't factor out 5 because it doesn't end in a 5 or a 0. So 5 is out. Let's try 7, shall we? 2023 divided by 7 using my calculator. It's 289. So it's 2, 4 times 3 times 7 times 289. And as we all know, 2289 is 17 squared. So this is the factorization is 4 2s, 1 3, 1 7, and 2 17. Bam! This is our factorization here. And now we want to calculate how many rectangles it has. And now there's an interesting trick here. Let's see, this is 2 to the 4th. This is 3 to the 1st power. If there's no power, it's the 1st power. This is 1 again. This is 4, 1, 1, and 2. Which means the number the number of factors, the number of rectangles 97,104 has is 4 plus 1 times 1 plus 1 times another 1 plus 1 times, this is 2 plus 1, which is equal to 5 times 2 times 2 times 3. 5 times 2 is 10, 2 times 3 is 6, equals 60, which means, let's just keep a log here. Step 1. Step 2. 60 rectangles. Yes, it actually does have 60 rectangles. This trick is pretty useful, actually. 3 first times 7 times 4 times 17, just like. Anyways, let's move on to step 3.
Step 3. Look inside.
Yeah, I'm pretty sure 97,104 isn't the summation of any simple little sequence, so we can skip this step. Step 4.
Step 4. Play with pattern.
Nope, I'm not getting 97,104 blocks for this, and even if I do, it's gonna take like a real lot of time, so I'm gonna skip step 4 as well. Plus, both step 3 and step 4 can be included in step 5.
Step 5. Join a club.
For step 5, I'm gonna search the number 97,104 in OEIS and see what you get. EGF satisfies AX equals what? What does AX even mean here? Okay. Yeah, let's skip this one. Let's see. Number of 3-step king knight tours. A king knight piece capable of both kinds of moves on an N times M chessboard. Okay. This one we can do. Basically, we have a chessboard here. We pretend this is infinitely big. Pretend this is a chessboard. Let's say we have a king knight. What's a king knight? Basically, we have a king knight piece here. This is I'm just not even drawing. Well, a knight can move to any of these spots. But king can move to any one of these spots. Well, here's a king knight. This king knight can move to any one of these blue spots. It can move to any one of these blue spots. Now, what do they mean by king knight's tours? Well, by king knight's tours, we have this. Let's just say this chessboard actually has a side. Now the king knight can move. You just make any move out these if they want, It has to go through all the points of the chessboard. It has to visit all the chests on the chessboard, but it cannot visit any place it has already been to. So it can't go back. Like king knight can go here first, then it can go here, but it can't return to here. Here, that's legal. Legal. So this is basically asking how many ways can the king knight do that on the board, on a board, a square board. It's not necessarily the 8 times 8 board, the traditional one. It can be like 11 times 11 and 13 times 13. It can be 100 times 100. But of course, on one of the boards, this is 97,104. It has 97,104 ways of doing the tour of the board without while visiting all the grids once and only once, all the squares. Area A of the triangles, such as that A, the sides, and one of the altitudes. Those are 4 constants, such as A, the sides, and one of the altitudes are 4 consecutive integers of an arithmetic expression D. So basically, we're looking for a triangle like this. See, this side is n, this side is n plus 1, this side is n plus 2. If that's not enough, this has to be n minus 1. Like this is n minus 1. Or maybe we can say this is n minus 1. It doesn't matter, but it doesn't matter. But this is an altitude, one of the altitude. We're looking for triangles like this. And n has to be an integer. N has to be a natural number. So it draws fancy n. I'm bad drawing fancy n's. But you get it. And one of these triangles has an area of 97,104. Wait a second, no. I got it wrong. It's actually n minus d, n plus 1d, n plus 2d. Yeah, that's more like it. D can be any number. It doesn't have to be 1. It just has to be an arithmetic expression. Like this can be n plus 2, n plus 4, n minus 2. Yeah. Anyways, step 6.
Step 6. More to explore.
97,104 is a meme. It's a meme in the number block community. Yep. That's literally it. No, I'm not going to draw the figure out form of number 97,104. Compound for eternity.